So thank you all for attending the water loss control webinar series today. As Avery mentioned, I am Nall, and with me today is James Markham. We're both research engineers, and we do spend a lot of time working in water loss control, and we're really happy that you could join us today. So the Southwest EFC's mission is shown here, and we do have a few words bolded for a reason. So in the context of water loss control, we feel that it's really important for systems to learn about and understand water auditing themselves. Even if you employ someone else to help you in the process, your involvement really helps you to learn about a lot of aspects of your water system that go far beyond water loss. We come at water loss control from a holistic approach, and we want the program you develop to be based on taking appropriate actions using your system's data. So this is the third session in our series, and the topic today is water loss control and the water audit. So we'll be looking at AWWA's free water audit software, which is sometimes called FWAS. I probably won't say FWAS, but you might hear FWAS. And as you know, or may know, that there was a new version of the water audit software released in December of 2020. And it's, 2020. And it's definitely an improvement over version 5. I'm trying to remember if it was 2020 or 2021. So James, I might have the date wrong. But version 6 does incorporate some changes that are more than cosmetic, and many states are choosing to delay its adoption. So instead, they're requiring the version 5 of the audit software to be used for submissions this year, and in some cases, possibly next year as well. Version 5 is well tested and it's well understood, so many of the states have decided to stick with it for the time being. Specifically, if they have auditing requirements, because they use version 5 to develop those requirements. But that being said, sooner or later, version 6 will be a standard. So for example, California is expecting to adopt it in 2024, although that might change. And as I mentioned, there are some important differences between the two versions that are more than cosmetic. So it's vital that you, if you're completing the audit, or if you're a regulator, or if you're reviewing the audit, or if you're a consultant that works with systems on the audits, that you really understand the potential impacts that, transitioning from version 5 to version 6 may bring up with it. So we'll get into some of the specifics of those changes today and the potential impacts that that will have as we go through the session today. So feel free to ask questions as we go, and we'll address anything that makes sense at the time, and then we'll have time at the end for question and answers. All right, so we're gonna kind of jump right in. So if you've been to our prior sessions, you've probably heard the phrase auditing for action. It's a common theme for us. So why are you doing water audits? Well, hopefully it's because you want to know what's happening to the water you produce and then take actions to address any water losses. But maybe it's just to fulfill regulatory requirements. Even if it's because you have to do it, we think the best way to think of the audit is as a diagnostic tool that empowers you to take action. It really is one of many tools that you can and really should use for water loss control. The great thing about the water audit is that it tells you the magnitude of your problem or problems, if you have more than one, and it starts to point you at sources and some solutions. You can almost think of it as an end of the year inventory like a factory would have or a store would have. I know how much product I made, so what happened to it all? That's really what we're trying to determine. What got sold, what got lost, what did I give away? Did I give it away on purpose or on accident? What got stolen? And how does all of that impact my bottom line? So once you have an idea of how big each of those categories are, you can start to address them appropriately. So remember, the audit by itself won't save any water. You have to actually do something, take some action to save water or to gain revenue. So that's really where we want you to view the water loss audit, is in the bigger picture, that it is one of the tools. So why do this water audit? Well, to gain knowledge and to take action. The audit will help you know what's going on in your system, because to complete the audit, you have to gather data, you have to review your policies, your practices, and procedures. So it gives you good insight The knowledge that you gain from the audit results in the process of developing the audit data and in asking questions about the data puts you in a position to take action based on real information. And the potential actions you take might vary, and that list is really broad of what kind of actions you can take, but it might be getting better data, it might be revising policies, it might be doing more leak detection, or doing some research to discover unknown sources of identified loss, or any other number of actions. But the point is that the audit helps you. It shouldn't be something you have to do, check it off the to-do list and put it away. Even if loss doesn't seem to be an issue in your system right now, having data now will help you understand changes to your system over time and be able to plan for repairs or replacements. So to reiterate, you should audit for what it can tell you and then take action based on what you learn from it and other analysis that you do. So now let's really dig into the audit software. Specifically, let's take a look at what it is, what it isn't, what it can tell you, and what it can't tell you. So the water audit itself is the AWWA standard approach to categorize or account for all of your water. It provides information to help prioritize actions. It provides metrics to examine non-revenue water over time. It provides overall volumes and values of water in those different categories. And on the screen now is version 5 of the software. It's what you probably are most familiar with, but we will be digging into both version 5 and version 6. On the other hand, the water audit isn't completely accurate, no matter how much work you put into it. It's a model, it has some assumptions, and the results are only going to be as good as the data that goes into it. And the audit was formatted for easy adoption so that systems could do it themselves. But just because it isn't perfect doesn't mean it isn't useful. It isn't the only option to determine what actions to take. And in fact, it shouldn't be the only tool that you use to decide what actions you take because it doesn't consider comprehensive benefits. It only considers the cost of water and the lost revenue from apparent losses. We want you to remember this, the triple bottom line. There may be other non-monetary reasons for engaging in water loss control, but the audit can't calculate directly. So you should be looking at the audit as one method and one type of analysis, but knowing that you want to consider the triple bottom line in why you're looking to conserve water or to reduce water loss. And finally, the water audit can't separate out your real water loss into its components. It gives you the overall magnitude, but it doesn't tell you where that water loss is happening. So if, for example, you won't be able to know from the audit how much of your loss is coming from your mains and how much is coming from your service lines, but you will know the total magnitude, and that gives you a good starting point for learning more and taking actions. So it won't tell you everything. There isn't enough information in the inputs to allow that, but that's not really the point. The goal is to show you the big picture so you can determine whether you have a non-revenue water problem, and if so, what kind of problem you have and how big that problem is. So we can use a medical analogy here. You can see on the screen, the audit's a little bit more like a blood pressure cuff than an MRI. It's an inexpensive tool, and it can tell you if you have a problem. It can be used to track the severity of the problem over time. It gives you valuable data, and it lets you know something's wrong, but it's not going to tell you why it's wrong or what the source of your high blood pressure is or how to lower it. You have to do some more work for that, and you have to use the appropriate tools to solve the problem. So a lot of similarities to what we're looking at with the water loss audit. So the audit does have some limitations, but as long as they're understood, the water audit can be a really useful part of the overall water loss program, both in terms of defining the non-revenue water problems you're facing and tracking the efficacy of the solutions that you implement over time. We're going to show you both versions of the audit and start to point out the differences. So this will be just a brief overview so that we can stick to time today, but we're happy to go more in depth with you if you've got questions. Please just send us an email and we'll share our contact information at the end of the session today. So your audit covers a specific physical area, and you are the one that has to decide what the physical boundaries of the audit are by defining the entry points and the exit points for the water in your system. And typically you're going to do that using your maps, your as-built, a GIS system. You want to really look at where all the water is coming in and going out and what you're really trying to analyze. So audit inputs can include things like wellheads, surface water intakes, an interconnection to another system, or some combination of those three. The important thing to remember is the boundary you set determines what you have to track for the audit. So if your audit's going to be source to sink and you have wells or you have an RO system, you have to include the well flushing or the brine discharge in your consumption data. If on the other hand, you're performing an audit just on your distribution system, you could start at the output of your treatment plant and not have to worry, at least for the purpose of the audit, about what was happening upstream of the water plant output master meter. For some systems, this is a pretty easy thing to determine, and for others, it can be way more complex. So it's really worth kind of taking the time and thinking about those boundaries. On the output side, you're really trying to identify all of the physical consumption, whether it's authorized or not, and all of the errors or things that could cause data to not look the way that it should, that are going to cause your numbers to need to be adjusted. So you want to think carefully about your water sources and your points of use and clearly define where the audit starts and stops. Also, you don't want to combine distribution systems that aren't physically connected. And even if they are physically connected, if it's one connection point, you may not want to put them in the same audit. We've seen audits that consolidated up to 7 separate systems. We don't want you to do that. If you do, you're going to lose valuable insight. So if you had a high loss system combined with a low loss system, it would make it look like you have 2 systems with moderate losses, and that's not the reality at all. And it's not useful to you. It's not telling you anything. So really consider what you're wanting to analyze and the information you're trying to gain. Next, you also have to understand the time frame. The audit should be used over a 1-year period, and that can be a calendar year or a fiscal year, but you have to align all of the inputs and the outputs to that time frame so that you don't over or undercount either your production or your consumption. So sometimes that means you'll have to prorate some of your meter reads that maybe are done on the 10th of the month, or it's not a perfect end of the month reading. So pick a time frame that works for you and stick with it going forward. Once the parameters are set, there are 5 general categories of data about your system that you're going to input. First is your basic system information. Next is your supply data, then your consumption data, your system characteristics, and finally your financial information. And the financial information is mostly related to the cost of acquiring and producing water and the revenue that you generate from sales. So let's look at each of these categories a bit deeper and have a discussion about what you need to put into each of these categories. So for system information, this is really the data entry form for your basic system information. The year of the audit, the units of measure, and the units of measure must be entered in order for the audit to work. So if you try to get started and you don't go put your units of measure in, it's not going to work at all. And so for version 5, this is entered on the instruction tab. For version 6, as you can see here, it's entered on the start tab. So version 6 also has some new fields that allow you to choose a water system structure. So you can choose retail, wholesale, hybrid, or other. You can also choose a water type: potable, raw, recycled, or other. There are also fields to track your validators information if your system chooses to or is required to validate your audit. And version 6 has room for your system's estimated population. So this is not your number of connections, it's your population. The number of connections goes elsewhere. So make sure that the contact person that you list, unless you're required to list who the director or the manager, make sure that the person that you list is the person that really has good knowledge of the audit. And then, that way, if there's questions, the contact person is the appropriate person to be reaching out to. If that is the director, that's great. But if not, don't put them in there. Make sure that that person is a useful contact, unless you're required to list the manager or director. to the reporting agency. So next is the reporting worksheet. This is where all the other data goes. This is where the magic happens. So it's called the reporting worksheet in version 5. And in version 6, this tab is simply called worksheet. So you can see they're looking a little bit different. And we're going to, again, dig into some of those differences as we go through today. The data input for supply data starts here. This is where you really get into the data input. This includes all the water you supplied. So we've got version 6 on the top. Sorry, I said that backwards. We have version 5 on the top and version 6 on the bottom so that you can compare and contrast those. So these volumes include water from your own sources. This will be any water from your wells, your surface water intakes, and it includes any water you import. So this would be anything that you get from like a neighboring connection, water that you purchase, and then finally you have water exported. In other words, water that you're sending to a neighboring system or that you're selling in bulk. So the three of these together make up the water supplied to your distribution system. So your own volume plus your imports minus your exports equals your total water supplied. Data for these inputs is going to come from your meter readings. So on the inputs and outputs you have here, you need to be reading meters. If you don't have meters, you need to be estimating to the best of your ability. So this could include well meters, master meters, raw water meters, treatment plant entry point meters, and export meters. An important thing to note is that these data points are critical to an accurate audit. If you undercalculate your inputs, you're artificially lowering your real loss. And in some cases, that could even end up with negative water loss, where your outputs are greater than your inputs. If you're doing that, you should be filthy rich because you're creating water. So of course, that's not really physically possible. And it's an indication that you need to go back to the drawing board and review your data. So two fundamental issues to be aware of are changes in internal storage and the timing of your meter reads. If there are changes in system storage between the start and end of your audit cycle, you want to take those into account. Water pumped into the system but that's not yet consumed can disappear if you aren't paying attention to the storage changes. Especially if you have very large storage tanks and it happens that your tank was closer to empty at the beginning, or vice versa, your tank was closer to full at the beginning and empty at the end. You want to make sure that you're aware of that volume that's being held in the tanks. If your meter reads don't line up with the calendar parameters you set, so if you picked a calendar year, January 1 to December 31, you may have to prorate your production to match, and you'll have to do the same on the supply side, more than likely. So to put the water supply data into the audit, you have to know where you collect and store it. You'll also want to keep an eye out for data errors. So you want to watch out for things like misreads and recording errors, particularly if your system collects this information manually. So if you're having, a meter reader read the meters and write it down somewhere, and then you're transferring it to a computer, you've got multiple occasions where error could be introduced. You can read the meter wrong, you can transfer the information incorrectly, you might sum it incorrectly when you're preparing the audits. Just be careful and be aware of the potential there. Also pay attention to data drops that might lead to incorrect volumes if you have SCADA. We worked with a system recently that noticed over time the volumes recorded by their SCADA system in the office and the volumes tracked on the actual meters had drifted because of signal drops and the errors between the meter and the SCADA system. So they were using the office SCADA data for their audits, but that data was out of sync and under registering the supply volume, not because the meter wasn't calibrated, but because of data transfer errors. When the staff noticed this, they started periodically adjusting their data to match the meter registers, but they didn't develop a good SOP for this and tracking whether or not it had been done. This system had over 200 wells, and that simple lack of a procedure made it extremely difficult to determine whether the right data was being used for the audit without a lot of digging and going back to see, had it been adjusted? What are the numbers? So just be aware that your SCADA is a communication, and you could have times when there's lapse in data recording. We know that no meter is perfectly accurate. Therefore, we want to account for that in the audit. Each volume entered for water supplied has an adjustment field associated with it. One for volume from owned sources, one for imports, and one for exports. You can make these adjustments as percentages or as a volume. So this can be used to account for meter error or changes in storage volumes, as I mentioned before. And in version 6, they're here. And instead of a radio button to select percent or volume, there's a pull-down menu where it says percent. If you change that, a new field appears here where there's currently a blank spot. So as I said, the audit was developed for ease of use and simplicity. So there's a single adjustment field for each of these inputs. So what do you do if you have multiple sources? You have to calculate a weighted average error. So we're going to kind of walk through just a quick example of why this is important. So let's assume we have 3 wells, and let's assume that for this case, they're over-registering. And the first one's over-registering by 1%, the second one by 2%, and the last one by 3%. So if we take a simple average of these, we come up with 2%. And if we use that simple average, we would adjust the volume supplied by 530 acre-feet. That needs to be removed from your production, and the audit does that for you. But what if your wells aren't producing equal volumes? It varies, and that's pretty typical. So you get 10% of your total production from that first well, 30% from the second well, and 60% from the third well. If you do a weighted average, the error is then 2.5%. So you should be subtracting 659 acre-feet. And I know not all of you use acre-feet, it could be millions of gallons, but for the example here, we've used acre-feet. So if you use the simple average, you would be under adjusting for the actual error. And the difference of 129 acre-feet would show up on your audit as real losses, because anything you can't account for in the water supplied shows up as real loss. So the same principle applies if your meter's under register. So we'll walk through kind of that same example where we have the 1% overread, the 2% overread, and the 3%, and the simple average is again 2%. And if we look at the adjustment, we'd have a 551 acre-feet adjustment with the way that the software would calculate your adjustment. But again, if you aren't having equal production from each well, so we have 10% at the first, 30% from the second, and 60% from the third, that weighted average error is again going to be 2.5%, which would equate to 692 acre-feet. So in this case, using the simple average, the audit would add 551 acre-feet, but the weighted average adjustment should be 692 acre-feet that should be added to your supply volume. So if you use a simple average, you would again be under adjusting for your actual error, and the difference of 141 acre-feet magically disappears from your real loss because you can't see it, you can't accurately address it. So you need to be aware, and again, you're using averages, so that's where some of the inability to be completely accurate comes in. But if you use weighted averages, you're more accurate than if you use just an average. Be aware that there are possibilities for other issues that can impact your data. One example is a system that we're working with now. They've got an interconnect with a neighboring system, and the valve that allows water to flow in from that interconnect is operated automatically. And they're not really sure if they have complete information detailing when it's been opened and closed over the last year, how much water they've actually received from that neighboring system. The next part of the audit moves into the consumption side of things. So here you'll need volumes for both billed and unbilled consumption. There are 4 categories of authorized consumption here. You have billed, whether it's metered or unmetered, and unbilled, again, metered and unmetered. You might not need to enter data in each place. So billed volumes are customer consumption that you're getting paid for. If you have meters on all of your customers, you might not use the billed unmetered category because you're completely metered. Unbilled volumes are those that you aren't getting paid for, and these could be metered connections that don't get charged, maybe a park or a municipal building. Or it could be something like a fire connection. For the unbilled, unmetered volume, you have 3 options. You can use the pre-populated default percentage. You can use your own percentage where you overwrite that default value, or you can input an actual volume estimate. This is where the volume differences between version 5 and version 6 really start to show up. The default percentages are different. The default value is 1.25%, and the version 6 default value is 0.25%. The percentage value changed, but so did the calculations. So we're going to talk about the volumetric changes first. So here, these 2 audits, the different versions use the same data. The version 5 default value, 1.25% of water supplied, comes out to 336.477 acre feet. The version 6 default value, 0.25% of billed consumption, comes out to 62.941 acre feet. So version 6 default uses a smaller percent of a smaller number. So version 6 is decreasing the unbilled authorized portion of non-revenue water that the audit reports. The next inputs are for your apparent losses. This is where we try to account for consumption volumes that result from theft, customer meter errors, and data handling errors. And they switched the order in version 6 for some reason. So theft is apparent loss. It reaches a customer, but it isn't counted, so you don't get paid for it. And by definition, theft is hard to quantify. Effective theft is theft you don't know about. So the audit gives you a default option to use if you don't have any theft information tracked. And this is another place where there are slight differences between the 2 audit versions. So version 5, the default value is 0.25% of water supplied. So again, that would come out to 67.295 acre feet. In version 6, it's 0.25% of billed consumption. So that comes out to 62.941 acre feet. Version 6 uses the same percent, but of a smaller number. So again, we're decreasing apparent loss values by using the new defaults in version 6. Another volume to track in apparent losses is customer meter error. Customer meter error adjustments apply to both billed and unbilled metered consumption. Like the source metering, you have 1 field for the composite error, so make sure it's a weighted average. You want to consider the types of customers, typical flow rates, meter sizes when determining what adjustment to make. So you want to, consider what does your testing program look like? Are you factoring in composite errors? And then really think about what you're sampling. So are unbilled meters part of your testing program? If you have significant unbilled metered consumption, they probably should be. So, if you have parts where you're giving water away, you want to make sure that you're monitoring those. To get statistically valid meter error data, you need to do random sampling of your meter population. So testing the known faulty meters alone isn't a random sample. Meter error from tests of suspect meters is usually not representative of the whole population. Also, large meter error isn't going to be representative of small meter error. So to get an accurate meter error, you need to do random sampling of your meter population with a sample population big enough to be statistically valid. So think about what meters to test, how you collect the data, what the data you have actually tells you, and how you're deriving any customer meter error adjustments. Of course, customer meter testing isn't free. It takes time and money, so you should weigh the costs against the benefits as well. The last input for apparent losses is for systematic data handling errors. There is a default value available to use. It is 0.25% of the billed metered consumption, and that hasn't changed from version 5. In order to estimate your errors instead of use the default value, you'll need to do process reviews and billing and other system audits. You want to make sure that your meters are set up correctly in your billing so that the volumes the meter registers are what gets charged. We had a system with a decimal in the wrong place, so they billed 1 gallon instead of 100 gallons. When they were reading the meters, it made a shift in what they were billing. Make sure the meters make sure the meters are actually set up correctly. We've talked with the system that replaced registers on some of their large bore meters, and it read differently. And as a result, it ended up with incorrect volumes for those customers. You want to make sure that customers are set up correctly so they are tied to the right customer class. You want to make sure that rate tiers are set up and applied correctly and uniformly. You want to make sure all your meters are actually in your billing system. We've worked with several systems where when we've looked what's in the field, what's in GIS, it doesn't match up with what's in the billing system. Make sure your billing functions work the way you think they do. Again, you can find these errors by doing billing system audits or process audits. So I've been talking about defaults that the audit gives you, and there are advantages and disadvantages to using them. When we've looked at different state data sets, we do see that it varies from state to state, but we've seen it as high as 77% for unbilled unmetered, 94% for theft, and 75% for systematic data handling errors. So for the most part, folks are using the default values, but the default values really are kind of a one-size-fits-all option. So like medium width shoes that some brands offer, that's the only thing they offer. It might work for most folks, but they may not work for you. So do the defaults fit you? Do you know? This is a good argument for using your own data if you have it. And if you don't have it, I think this is a good reason to start developing it. In most cases, you'll be able to develop some time and flow calculations to get a good idea of what you're using. And others, you may have to do some more research and make better estimates, but really get a good idea of if the data fits, the default values fit your situation. So that, of course, begs the question, can you estimate any of these volumes with accuracy? And the answer typically is yes. For things like fire use, street cleaning, flushing, those can all be estimated using simple flow or volume, simple volume or flow times time calculations. If you don't know flow rates, you can start by measuring pressure. There's lots of tools out there that you can use to calculate flows if you don't know what they are. So use the defaults the first few times if you need to, but you likely won't, because you probably won't have that data. But you really should begin estimating and tracking what you can to determine whether the default approximation is a good one for you. So the last part of the audit is to include information on your system. This data is going to impact your key performance indicators. So you want it to be accurate for your KPIs to be valid. So you need to include the length of your mains, how much piping you have, and you can gather this from your maps, your as-built, your GIS, or maybe your CMMS system if you have one. Make sure you understand the data that you're pulling if you're using GIS, understand your layers, and what you're actually calculating there. You want to make sure you add the length of your fire hydrant leads to this figure. So if you had 100 fire hydrants and the average lead length was 50 feet, you'd have almost a mile of extra pipe to add. Another system characteristic is the number of connections. So you want to have the distinct number of connections to your pipe. Every service line, every connection is a hole in your pipe and a source for leakage. So you want to make sure you're counting them all. Usually the place to get this is your billing system, but make sure that you understand what you're getting. You want to have not only your active connections, but also the inactive connections. If that abandoned house still has a service line, it should be counted. And that also goes for emergency fire connections to buildings. But again, this doesn't include your fire hydrants. We already took care of that in the length of the mains. So the total number of connections may differ from your active accounts in your billing system. So you might have to look to other systems if you're not able to use your billing system to get all of those connections. So things like asset management programs, GIS data, might help you to get the right total or to verify that the information your billing system is giving you is correct. You want to put your average length of your service lines in. So this is a question. Are your meters at the curb or property line, or are they in or near the home? So answering this question will affect, how much loss you could potentially have in your system. Average system pressure is necessary for your unavoidable annual real losses and your infrastructure leakage index, and we'll dig into those a little bit later. If you have a hydraulic model, that's where you should go. If you don't, you can build a pressure map using pressure data from your hydrants. You might have that data, or you might be able to get it from your fire department. And again, you're going to want to do a weighted average. And finally, you'll need to include some financial information. Mostly this is going to be related to the cost of acquiring and producing water and your revenue generated from sales. You'll probably get this from accounting or billing or both. But make sure you understand how any financial credits work in your billing system. If you give rebates for leak repairs or for swimming pool filling, you want to make sure you understand and factor those in appropriately. So for the customer retail unit cost, you have to come up with a composite cost that represents the average charge for a unit of water. This cost is used to value apparent losses. So it's not all of your revenue, it's the average volumetric commodity charge across all of your customer classes and your rate tiers. Some other costs like base rates or connection fees don't factor in here. But if you have sewer revenue or stormwater charges or biosolids processing or any other charge that's based on volumetric water consumption, you have to include that revenue when you determine customer retail unit cost, because every gallon of water that a customer gets but doesn't pay for not only hits your water revenue stream, but your wastewater revenue stream. So again, it's about those volumetric charges. And this can get kind of tricky when you have different rates for different customer classes, but we have tools that can help you figure this out. So make sure that you reach out to us if you've got concerns or questions about how best to calculate that number. And then operations costs have become optional in version 6. In version 5, you'll want to include your energy and chemical costs here at the very least. So now that we've walked through the data inputs, I'm going to turn things over to James to discuss data grading and KPIs.
There's some changes between version 5 and version 6, which kind of beg the question, which one should I be using? And for those 3% of you, I think it was, that have done both, that's the right answer. I think if you're just starting with water auditing, use version 6. That's the current standard. It's got the current industry metrics, which we'll talk about here in a minute. If you've been using version 5 for past audits, or you're from a state that uses version 5 now, look at both, because there are going to be changes, and how those changes impact your system is going to depend on how you collect your data, which defaults you use, etc. And if you've already developed data for a version 5 audit, it's really just a matter of transferring that information into a new spreadsheet and seeing how the results are impacted. It gives you a chance to see your results with the current metrics, which I'll cover in a second. And it gives you a chance to look at how the data grading process has changed and what, if any, impacts those are going to have on your data validity score. Let's talk a little bit about data grading, what it is, how it works, and what it means. Data grading is a qualitative overview of the audit data points. There's basically 3 components. Each data point has a data validity grade associated with it. Those grades get added up for a total data validity score for the whole audit, and that score is then used for loss control guidance. It falls within a variety of tiers. What data grading looks at is your policies, your procedures, your practices, and the results of those practices. Another way to think about that is, what you've decided you're going to do, how you've decided you're supposed to do it, what you actually did, and then what those results are. And again, this is, I think, the really powerful piece about the data grading process. It gives you an opportunity to review policies, practices, procedures, and results and see if change is necessary. I've quite often been helping a system do an audit, and we get to questions about source meter accuracy, and I get told, oh, our policy is to test meters every year, but then when we go to look for the latest results, we realize, oh, there's actually no tests for the last 2 years because of budget reasons, and the results from the year before that are missing, and actually it's not even written, and the 1 meter we have isn't even testable because of how it's installed. This is the kind of thing that the audit data validity is trying to get at, how reasonable and accurate your data is likely to be. So it's, I guess, important to approach this process with an open mind and look at it as an opportunity for critical evaluation and change. As I said, data grading is a qualitative process. It's not quantitative, which basically means that it's a proxy for statistical accuracy assessment. It is not statistical in and of itself. There's some numerical criteria that are considered, like the percent of sources in your grade for volume from own sources. But the process isn't about determining the statistical probability that the number you put in any field is exact or correct within plus or minus X%, and neither is the total data validity score. The basic idea is that the more rigorous your practices, policies, and procedures are, the more likely it is they're going to produce accurate, good data, and the audit tries to assess that in a relatively uncomplicated manner using criteria that were put together by a panel of experts. So data grading is not about statistical margins of error. A data validity score of 80 does not mean you have an 80% confidence in the audit results. And it's also not like a report card where 98 is an A and 80 is a B. And it's not a value judgment. It's simply an assessment of your policies using a list of criteria that a group of experts have put together. Version 6, the data grading is a really easy process, and this is one of the best improvements in the water audit itself. It's a question and answer format. There's a list of questions associated with each data point. On the left here, you basically pick the best fit answer from the column on the right, and it calculates a data grade for you. And it also tells you what the limiting factor is. So in this case, the grade of 7 is limited because of how electronic calibration is handled. So that gives you some ideas about things that you could do to improve the data grade. In version 5, which you're probably more familiar with, it's a little bit more work. You have to hover your mouse over this little red corner, pops up a window, and then you read these lists of criteria and determine which one fits you best, basically starting at number 1 and seeing if you meet or exceed all of the criteria, and then moving on up through the list until you get to a point where you can't meet or exceed all of those criteria. In some cases, you're going to be in one of these in-between conditions. So 3 is the grade that you would apply if you met all the or exceeded all the criteria in grade 2, but not all of the ones in grade 4. So similar kind of situation, but it's a little bit from a format, a little bit harder to deal with. And these statements are relatively dense, so you have to look at them very closely. There's up to 20 data grades, one for each data point. It's actually 19 in version 6 because of the optional operating cost value now. They're all graded on a scale from 1 to 10 or not applicable if you don't have that data point. The easy thing about them is where you put them. They just go to the left of the data point question, although sometimes it's very far to the left. The apparent loss values are actually on the right side of the page. Important to remember that these are not uniform grades. You don't grade the first one, get a 10, and then apply that across the board. You could have a 10 for one data point, 2 for another. They've got their own criteria, and they have to be evaluated separately. And I'll show you what I mean. We're going to look at some criteria related to metering on the input side and the output side. So if you look at the criteria for volume from own sources, you're looking at the percentage of sources that are metered, meter accuracy testing and calibration, meter accuracy results, and a review of procedures by a third party knowledgeable in M36 methodology. So you can look at these criteria and recognize that, yeah, these are going to impact how good my data is. If I don't have all of my sources metered, I'm guessing or estimating on some of it. It's not going to be as good as if I have accurate meters everywhere. But this last criteria, you notice it says somebody who's knowledgeable in M36 methodology, which is water auditing, not an M6 methodology expert or an M6 expert. And M6 is the AWWA's meter testing manual. And this kind of hints at the fact that not all the criteria are necessarily going to be appropriate for your utility, and that this is not about trying to get the highest grade possible so that you can say, look, Mom, I got a 95. In this case, third-party review is required for a grade of 10. That might not be important to your system. You might not need to do outside validation. You might not need to afford it. You might actually have an internal expert in water auditing who understands this perfectly, but isn't a third party, so you can't count it for the data grade. So that's the system input side. Let's look at a consumption side criteria list. And in this case, we're looking at billed metered consumption. And the criteria, although similar, are different. It's the percent of customers with meters and volume-based billing. It's about your meter reading practices, whether they're manual or automatic. It's about records retention and handling processes, and about meter replacement practices. So again, relatively clear that these are going to have an impact on how close the billed meter volume you enter is going to be to what reality is, but they focus on slightly different things. And again, here you can see that these criteria don't directly address the numerical accuracy or the statistical accuracy of your inputs in any real way. The other thing to point out is that they're not weighted equally. You probably noticed you got 20 or 19 points, data points with a grade of 1 to 10. The data validity score is out of 100. So the different data points are weighted differently. Some of them are going to have, particularly those related to your source volume, are going to have a much bigger impact on your overall data validity score than some of the others will. The good news is we actually developed a tool several years ago that does the grade version 5 grading in this question and answer format like we have adopted in version 6, and this is essentially the precursor to that. That being said, this is not an official AWWA tool. We found it to be very accurate and to give good results. But if you're going to use this, you should compare its results to what you get looking at the audit itself. So some basic changes between the two systems. And by the way, this is available on our website, or if you reach out to us, we can send you a copy. There's some changes. It's a lot easier in version 6. The criteria are a lot more granular in version 6. Some of the version 5 audit criteria are a little indistinct, shall we say, but it's still a qualitative, not quantitative assessment. And again, we've got that tool. There's also a paper-based version that you can use. In version 5, there's a pretty big emphasis put on the data validity score as this sort of proxy for accuracy. It shows up on the bottom of your worksheet, along with some priority areas for attention. These are things that are going to improve both your data validity score and presumably the accuracy of your audit if you address them. It also shows up on the KPI page. But the thing I like best about the data validity score is that it's useful for loss control planning, because your score falls within a tier in this loss control planning guide, which is one of the tabs in both versions of the audit. And it gives you some ideas about things you can do based on the validity score that you have, sort of based on the goodness of the data that you're likely producing. If you've got a really low data score, it's probably better to focus on getting better data and doing initial research rather than to run out and start to try doing benchmarking with inaccurate data. If you've been auditing for a long time, you've got really tight processes, then you start looking at things like long-term loss control and target setting and benchmarking. The nice thing about version 6 is it, as I said, it sort of de-emphasizes the data validity score, because, to be honest, what's the big difference between a 67 and a 69? Probably not much, although there probably is a qualitative difference between a 50 and a 60 or a 50 and a 70. So recognizing that, the committee kind of de-emphasized the score and emphasized the tier, because this is really about tracking and water loss and doing water loss control planning. So you've got the same priority areas for attention, but the data validity score actually only shows up on the dashboard along with this nice gauge that shows you which tier you're in and sort of how close you are to the next tier. And then the control planning guide is exactly the same, except for the titles. These used to be called levels, now they're tiers, but the content of them is exactly the same. So you've got some basic changes, in format. The scores are still 1 to 10, although in version 6, sometimes those in-between grades aren't actually available. One of the big changes, though, is the value of the defaults. In version 5, a default is worth 5, is graded as a 5, and in version 6, it's graded as a 3. And that can actually have some impact on your overall data validity score. Now, we haven't regraded every audit we've ever done, but we have done a lot of them side by side to look at them. And based on our experience and the experience of colleagues that we've talked to, in highly metered systems, it's likely that your data validity score is going to change by a point or two. Usually it goes down. We've seen some where they go up. And in that case, you're probably not going to see a change in the data validity tier unless you were sort of sitting next to the margin. That being said, if you're an unmetered system, particularly if you have no customer meters, maybe you're one of those systems that just does flat rate billing, you're probably going to see a 6, 7, maybe even higher point drop in your data validity score. And that is potentially going to drop you from one tier to another. Main point I'm trying to make here is be realistic about the grading. Like I said, it's not a value judgment. I think the problem with having it on a 100-point scale is it looks like that report card, and I've talked to board members and managers who want to know, why didn't we get an A on this? Why didn't we get 100? And that's really just the wrong way to look at it. I've seen systems that have relatively low data validity scores because they have a lot of manual procedures, and the data validity scores are kind of, at least in version 5, are kind of weighted toward automation. But I've seen, low DVS audits where I trust the data a lot because I know the systems are very tight and the data collection is very tight. Whereas I've seen audits from, larger systems that are very automated, and as a result, have higher data validity scores whose data I do not trust as much. So again, use this as an opportunity to analyze what you do, see how effective it is, and make changes. And the right data grade for each one of these data points is the one that reflects your practices. I know we're going to run a few minutes over, but I'll keep this short. I want to talk a little bit about interpreting results. In version 5, you've got a dashboard that gives you color-coded water balance and two ways of looking at your losses: volumetric, which is this one here on the right, and revenue-based, which is one on the left. And I think it's important in version 5 to look at both of them because they're not displayed simultaneously. Because as this example clearly shows, in many cases, your biggest volume of loss is not going to be your biggest revenue loss. In this case, on a volume basis, it's real loss. This orange column, that's the problem, but that actually only amounts to a small piece of the revenue that this system is losing. One of their bigger problems are actually unauthorized consumption and meter error. So look at both of those. There's also the KPIs, the performance indicators. I'm sure most of you are familiar with these. It's the old versions. They're a combination of normalized metrics per connection per day and these percentage metrics, and those have gone away in version 6, and I'll show you that in just a second. And then, of course, we've got our data validity score up there, which is our sort of proxy for the goodness of the data. In version 6, everything's combined into one easy-to-read dashboard. You've got your validity information up here. You've got the side-by-side comparison, both in a graphical and table format, so you can really look at the volumes and costs. And then you've got the key performance indicators. And the nice thing about version 6 is we all want to know, like, are we keeping up with the Joneses? And not only does this display the appropriate metrics for you, it shows where your metrics fall out in relation to a very, very large data set of validated water audits. I think there's about 2,000 audits in the system. So you can see, where your performance is as it relates to other utilities in this data set. That being said, I still think the most important thing about a water audit is to be comparing yourself against yourself last year to see, whether you're holding the line, whether you're doing things better than you were. And also, version 6, like version 5, presents these values as very sort of authoritative single values when they're really actually numbers somewhere in a range. And the audit itself is not going to give you that confidence interval. You've got that proxy in terms of the data validity score, but if you want to know sort of how big the confidence interval is for your particular loss metrics and KPIs, there's additional information you have to do. So like I said, there are no more percentage indicators, and that is a good thing. All of the metrics are normalized. So it's, losses per connection per day, real, apparent, and total, and then cost rates associated with those real, apparent, and total losses, as well as real losses per mile per day, which is really useful for low density systems, and the infrastructure leakage index, which we'll get into a lot more in our real loss webinar. And here's the problem with percentages, and this is why I think it's a good thing that we've gotten rid of them. Assuming we've got a system, 50,000 connections, 27,000 acre feet of supplied water, 25,000 acre feet of consumption, which means we've got 2,000 acre feet of non-revenue water. We do our audit, tells us we've got 1,500 acre feet of loss. Normalized, that's about 27 gallons per connection per day. 5.6% of real losses supply as a percent of supply. Let's assume it's the next year and, system's in a drought. We've decided, hey, we're going to put in some conservation messaging to our customers, and our customers listen and they use less water. So we've got the same number of customers, but we're supplying less water because the customers are using less water. In this case, we've still got 2,000 acre feet of non-revenue water because we're holding the line on real losses. We're repairing leaks as fast as we can. We've got the same value of real loss in terms of acre feet. So normalized, we're still at that just under 27 gallons per connection per day. But if all we look at is the percentage, it looks like we have had an increase in real loss as a percent of supply. And this is why, the percentage metrics by themselves are problematic. Water conservation and water loss control go hand in hand, but if all you're looking at is losses as a percentage of supply, positives on the conservation side can actually negatively impact your water loss control numbers, not what's actually happening. In this case, we've got a system that's doing what it's supposed to. It's using less water, it's holding the line on real losses, but because it's using the wrong metric, it looks worse. So, we've talked about some changes in default values. We've talked about some changes in the data grading. What's the impact on audit results? The examples that Don gave us, we had a decrease in unbilled authorization and the switch from V5 to V6. We had a decrease in apparent loss from V5, V6. Where does all that volume go? It shifts to real loss. The non-revenue volume that it calculates is exactly the same, but because those percentages and what those percentages are multiplied against have changed, the individual volumes in those individual categories have changed. Has anything changed on the ground? Of course not. But the results look different. And this, again, is why I think it's really important to understand how those changes are going to affect your utility. If you don't use any of the defaults, you probably won't notice a change at all. If you use all of them, you could have a big change coming, and you want to be able to answer the questions that are inevitably going to be asked if you're in a situation like the one I just showed you, where, with effectively the same data in 1 year, you've got 1,000 acre feet of real loss, and the next year you've got almost 1,300 acre feet of real loss. It looks worse, but it's not your fault. It's because of changes to the audit. So if you just looked at the numbers without being able to explain this, you'd have, 28% increase in unit real loss and a 23% increase in total loss when on the ground, nothing has changed. So understand the changes. Recognize that all things being equal, if you use all the default values, version 6 is going to calculate higher loss for you. And again, this is all about wanting accurate results. We want to have accurate data. We got to recognize that the audit accuracy is somewhat limited, and then balance our outcomes with efforts. In some cases, those defaults are going to work perfectly for you if you check and they work. Maybe you don't need to collect that data right now. Maybe you can put that off for later. But you definitely want to at least make sure that those are reasonable estimates for you. There's a lot of other tools that can be used to attack and better understand real loss and apparent loss, and we'll talk about those in our next couple of sessions, doing confidence analysis, leakage component analysis, break rate indexes. But I want to go out on a couple of very basic closing thoughts. Don already mentioned this. If you've got negative water loss on your audit, go back and look at your data. It's not physically possible, and it shows that there's something wrong. So start digging. And it might actually be that the defaults are a bad fit for you, particularly if you're using version 5. I've seen some systems use version 5, come up with negative water loss, go back and start actually trying to account for their actual unbilled, unmetered use, and realize that their actual number is much, much smaller than what the audit shows. And by using their own data, that negative water loss goes away. So, look at your data really closely. If you're using all of those defaults, look at your results with a healthy dose of skepticism. Think about whether it's time to start collecting your own data, at least to do a comparison to see that estimate that the audit is giving you is a reasonable one. And then again, be prepared for the impact that these changes are going to have. As I said, the most useful thing about auditing is compare how you're doing versus prior years to see, whether the loss control actions that you're taking are having a good effect or a negative effect. Every system has its own challenges. So it's great that version 6 has those dials in it, so you can sort of see whether you're keeping up with the Joneses. But more importantly, really try to understand how you're doing this year versus last year. That being said, version 6 is a lot easier. And knowing where you're at can sometimes free up funding. If your system is one of those where you've got a board that really wants to be at the top of the heap, having a set of gauges like this that show where you're at can be really useful. I think this dashboard and the current metrics alone are a really good reason to go ahead and transfer that data into version 6 if all you've got is version 5. Again, so that you can answer those questions that may come up when the switch actually happens. So with that, I know that was very fast and a lot of information. I'll open the floor to questions. I see we've got some already in the Q&A box. And while we're trying to answer those, I will put up our contact information and the contact information for Heather, our director, who you've heard from in some of our other sessions. And let's answer some questions. Thank you very much for staying a little bit over time here. And we'll stay on as long as it takes to get these questions answered. thanks for joining us, and we'll be back with you guys in a couple of weeks.
All right, James, we've got plenty of questions that came in, and I know we're over, and I apologize, it was my fault. So we'll try to answer questions. I've tried to answer a lot of the questions privately in the box so that if you ask a specific question, hopefully you've gotten an answer. But the ones that are coming in right now, we'll go ahead and address. And then maybe we can send this out as a follow-up kind of email to the group so that everyone gets a chance to see the question and answer. So one of the questions, James, is, and you can definitely answer this better than I can, for the approximately 2,000 reference audits used for the median KPIs, do they skew toward large or small systems? Is there a way to customize the KPI medians for small systems?
Well, I don't know the exact answer to that because I've got the summary data, but I don't actually have the initial data set, although I'm trying to get that. Auditing tends to be something that larger systems do, although many of these areas include states where audits are pretty much required across the board, even of small systems. So there is a significant small set of audits in there. And Dawn pointed out some of the changes in version 6 about the number of, not just looking at the number of connections you have, but looking at the type of system you have and the population you serve. The reason those changes were added was so that going forward, we will be able to suss out, more appropriate data to be able to sort of split the large data set into, small retail systems versus small wholesale systems. How do those compare against their, medium-sized and larger compatriots? So right now, I think there is something of a skew toward larger systems. That being said, I think as the next couple of years come out and we start getting more systems actually using these data, we'll see a more granular set of benchmarks. And the AWWA does present annual benchmarks of validated water audits. In the past, those have been a relatively small data set. I think going forward, we're going to have a much bigger data set and a much more robust data set that can be sort of sliced and diced a little bit better to get at what you're getting. Because, there are differences between small systems, large systems, denser systems, less dense systems. There's age issues there as well. So I guess the real answer to that is stay tuned. That's coming.
Another good question, is there a SI or metric version on version 6? I know there was on version 5, and I assume they carried it through to version 6, but
yes.
Okay.
Yes. So you have 3 options. You can do it in millions of gallons, acre feet, or megaliters, and you can actually do it in French if you're bilingual, because this is also the standard up in Canada. When I was referencing systems with the 6, 7, 8 point drop, that's actually information from Quebec, because most of their water systems don't have residential customer meters, and they did a big review of their audits and how the data grading was going to change them. There is an SI version on the instructions page where you put in your system information. You have to choose units there, and one of the units is millions of gallons. So,
great, thanks, James. Another good question: if my system backflushes, should I be calculating this as a loss?
No, that is authorized use. That is part of your process. You're doing it on purpose, I presume. And so that would go typically in that unbilled, unmetered use. And this is, again, why it's really good idea to try and use your own data if you have that information, because, if you're a system that does a lot of backflushing, a lot of well flushing, a lot of water quality flushing, that number may not work for you. So yeah, that is not a loss. And sort of as a corollary for that, if you're tracking breaks and estimating losses, that's great. You really should be doing that, but that information does not go into the audit. Just because you've estimated a loss for it does not mean you've somehow accounted for it. That's basically information you would use to compare against your water audit results.
James, we have a lot of questions about customer meters and accuracy, and the cost and the time associated with pulling and testing those, and can we test them in place? Do they need to be tested? Do they need to be valid? You know, do we need validation? So I think a lot of the questions are really concerned with the time and the cost of looking at customer meters and understanding you know, how many they need to actually test. And so we've worked with systems in the past that have partnered with neighboring systems where they go together to have one bench test system that they can all have access to. That's really helped them to decrease their costs. We've worked with systems that test meters in place, to, you know, and they're looking at random sampling. So they're looking at different locations, different meter brands, different meter ages, you know, a variety of things. So it is really quite a concern for a lot of systems. And, you know, for small systems, even with just 100 connections, you know, the revenue they're generating doesn't compare to a very large system, but they would have to test a much higher number of meters to get a statistically significant sample. So we do understand the question and concern there, and do encourage you to kind of think through what you know about your meters, and if you're using the data that you get when you pull a meter that's been, you know, someone's called and complained, or the meter's stopped and you've tested that meter, we don't want you to use that information and put that in your audit, because that's not a random sampling. Those are only meters that have been considered faulty or have concerns about them. So some people think, oh, I've got this data, I should use it, but it's not representative. So that's where we really want, you know, you to think about what data you have, what data you might be able to get, and what the, you know, how much is it going to impact your water loss audit results. So, you know, that's the beauty of a spreadsheet, is that you can put 2% in there and see how it compares to 0.2%, and make some decisions internally. So there's, you know, there is times whenever the cost benefit really isn't there, but we also don't want you to use data just because you have it and it's not good data. So hopefully that kind of answers some of your questions. We'd love to talk to you about your specific situation and see if we can make recommendations. So I think about a half a dozen people have, you know, reached out about specific topics. So feel free to email James or me, and we'd be happy to talk to you about it more.
Yeah, I would add one thing to that, and that being, like, you know, if you've got some money for meter testing and you've got a choice between testing customer meters and testing source meters, test your source meters. You know, particularly if you're a system that maybe wasn't originally built with well meters and they were added in later. We've got a lot of those here in New Mexico, where meters were kind of fitted in at some point and they were never actually calibrated, and nobody really knows whether they were accurate or not. That's the biggest number in the audit. So if that is wrong, you know, Dawn showed you some the implications of over and under estimates on your results. You know, I would start there, trying to figure out what's going on with my actual meters. And, you know, there's different ways of dealing with it. You know, you could actually have the meter itself calibrated. You could have somebody come out and strap on a meter that's, you know, a little bit further down the pipe and do the comparison. Because really what you want to know is what the adjustment is. You don't necessarily have to have your meter reading, you know, 99.9% accurate all the time, as long as you know how off it is. So, you know, if you're going to start somewhere, start with the source meters, and then, you know, later on, maybe step into the customer meter side of things.
Great, James. I'm sifting through some. Like I said, I tried to answer a lot of the questions directly, and we can share those as an email. It looks like Wendy already left. I was gonna reach out to one of the questions and say I'd like to talk to her directly, but it looks like I missed her. So
what was that person's? Write that person's name down, because we'll have the file afterwards and we can reach out.
Yep, I've got it. So I think we've addressed all the questions I haven't answered privately that we'll follow. You know, we'll share in the email. So we're, you know, pushing 15, 16, 17 minutes over time. So I don't want to hold people longer. I did want to address as many questions as we could. We really thank you for your patience with us and letting us try to cram as much into an hour as possible. And we'd be happy to hear from you via email. So I will turn things back over to Avery for last minute words here.
Great, thank you so much. I'd like to extend a huge thank you to our presenters today for sharing their expertise with us. And also a big thank you to everyone who attended. So following this webinar, you will receive a follow-up email with our survey and a link to the recording. We ask that you let us know your thoughts on today's session. As a reminder, session 4 of the series, Taking Action to Address Apparent Losses, will be held on Thursday, March 31st from 1 to 2 p.m. at the same time. And thank you again. I hope you all have a wonderful day.